All right, we've already talked about the fact that when we multiply two matrices together, that in general AB is not equal to BA. And we've said it's sometimes pretty obvious because the innermost dimensions won't be the same, and so it's not even possible to multiply one of these. But what happens if both A and B, it is possible, for instance, if they are what we call square matrices, where the number of rows is equal to the number of columns. Suppose A is equal to the matrix, and let's just make it pretty easy, 1, 2, 3, 4, and B is the matrix 5, 6, 7, 8. Okay, so A dimensions 2 by 2, and this is also a 2 by 2. So when we multiply A times B, we've got a 2 times 2 times a 2 times 2. The innermost dimensions are the same, so the outermost will be the answer. So we're going to get a 2 by 2 for our answer. How do we do it? Well, let's go through and just do at least this one. 1, 2, 3, 4, and then 5, 6, 7, 8. Now what we do is we turn this row sideways and multiply by there. So we've got 1 times 5, which is 5, plus 2 times 7, which is 14. So we got 5 plus 14, which is equal to 19. We keep this 1, 2 and move it across to there. So we've got this 1, 2, 1, 2 there. So 1 times 6 is 6, plus 2 8s are 16. So 6 plus 16, 22. Then we get the 3, 4, turn it sideways. And we've got the 3 there and the 4 there. So 3 5s are 15. 15 and 4 7s are 28. So that'll be 43. And you add those two, 15 plus 28 is 43. And then you keep the 3, 4 moving through here. So we've got a 3 there and a 4 there. So we've got 18 and 4 8's 32. So that will be 18 plus 32, which is equal to 50. Okay, so it was possible. So let's have a look at BA. B is a 2 by 2, A is a 2 by 2. So once again, the innermost dimensions are the same, so we're going to be able to do this calculation, this multiplication, and our answer will also be a 2 by 2. So we've got 5, 6, 7, 8 times 1, 2, 3, 4. Okay, we turn the 5, 6, put it that way. 5 there, 6 there, multiply that. 5 times 5. 5 times 1 is 5, and 6 3s are 18. So 5 plus 18 is 23. Keep the 5 and 6 going this way. 5 up there, 6 there. 5 2s are 10, and 24 is 34. 7 and 8. 7 goes up there, 8 goes there. 7 plus 3 8's are 24, plus 7 is 31. And the 7 8 stays there, 7 up there, 8 down there, 7 2's are 14. 14 plus 4 8's 32 is 46. Nowhere near the same. So in general, A times B is not equal to B times A when we're talking about matrices. That's called the commutative rule. General multiplication of numbers, commutative rule holds true. 3 times 2 is the same as 2 times 3. So it holds true for integers, for fractions, for decimals, but doesn't hold true for matrices. The other rule is the associative rule. If we had 3 or more matrices, A, B, C, which one do you do first? If it was written like that, we would actually multiply B times C first. and then we would put A at the front and multiply A times the result of B times C. Now, as long as you keep the order, it works that it does not matter which one you do first. So here we've got A, B, C, here we've got A, B, C. So one of the properties of matrices is that as long as you maintain these in the same order, it doesn't matter which two you do the multiplication first, or if you had a D in here, you'd have other combinations as well. So here we can actually do A times B first. Must stay at the front of C though. When we get our answer, we must put it at the front of C and then put C at the back. And then do that, multiply by that, and we'll find that those are indeed true. So the associative rule for multiplication of matrices is true. The commutative rule is not true. So when you change the order in which you do them, that is going to be not true, whereas you can maintain the order, that is fine.